When we look up at the night sky, it does not feel empty. It feels overwhelming. Even from a dark location on Earth, we can see thousands of stars with the naked eye. With telescopes, that number rises into the millions, and what we see is only a small fraction of what is there. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. That number is so large, it loses meaning. If you tried to count one star every second, it would take you thousands of years to finish. And the Milky Way is not unique. There are hundreds of billions of galaxies in the observable universe. Some are smaller than ours, some are far larger. Each contains its own billions of stars. The arithmetic becomes staggering. Hundreds of billions of galaxies, each with hundreds of billions of stars. Each star a possible sun, each sun a possible home. For most of human history, we did not know this. We imagined the universe as small, intimate, perhaps even centered around us. Modern astronomy removed that illusion. The universe is vast beyond ordinary comprehension. And in recent decades, we have discovered something even more important. Planets are not rare. For a long time, we did not know whether other stars possessed planets at all. Our solar system might have been an accident, an exception. Now we know that planets are common. We have discovered thousands of exoplanets orbiting distant stars. From this sample, we infer that most stars in our galaxy have planets. Many have multiple planets. Planet formation appears to be a natural consequence of star formation. Dust and gas collapse under gravity. A star ignites at the center. The remaining material forms a rotating disk. Within that disk, particles collide, stick together, grow into rocks, then worlds. This process appears to happen again and again across the galaxy. Among those countless planets, many lie in what astronomers call the habitable zone, the region around a star where temperatures could allow liquid water to exist on a planet's surface. Water is not life, but it is a powerful ingredient. On Earth, wherever liquid water exists, life follows. So we have billions of stars, billions of planets, and billions of worlds where temperatures are neither too hot nor too cold. Even if life is difficult to begin, the sheer number of attempts is enormous. If only 1 in a million habitable planets develops life, that still leaves thousands of living worlds in our galaxy alone. If only 1 in 1,000 of those develops intelligent life, there could still be civilizations scattered among the stars. And the galaxy is old. The Milky Way is more than 10 billion years old. Our sun is only about 4.5 billion years old. Earth formed even later. Complex life appeared billions of years after that. Technological civilization emerged only in the last fraction of that history. This means there has been plenty of time for other civilizations to arise before us. If intelligent life commonly appears on habitable planets, then some civilizations in our galaxy could be millions, even billions of years older than ours. A billion years is not a small advantage. It is not an incremental lead. It is an eternity. In a billion years, continents shift, stars move through the galaxy, entire species evolve and disappear. A civilization with that kind of head start would not be slightly more advanced than we are. It would be unimaginably advanced. And here is where the puzzle begins. Even traveling at modest fractions of the speed of light, a civilization could, in principle, explore or colonize the entire galaxy in tens of millions of years. That may sound like a long time, but compared to the age of the galaxy, it is brief. If even one civilization had developed interstellar travel millions of years ago, we might expect signs of its presence. We might expect to see large-scale engineering, artificial structures around stars, unusual energy signatures, altered planetary systems, something that does not occur naturally. We see none. No confirmed alien signals, no unmistakable megastructures, no galaxy-spanning civilizations. We have scanned the skies for radio transmissions. We have looked for unusual patterns of light. We have searched for waste heat that might betray advanced energy use. So far, the universe has remained silent. This contradiction between expectation and observation is sometimes called the Fermi Paradox. The question is simple. If the universe is so large, so old, and if planets are so common, and if life is even moderately likely, then where is everybody? Why do we not see evidence of advanced civilizations? Why is the sky not filled with activity? The numbers suggest that life should not be rare. They suggest that intelligence, given enough time and attempts, should arise more than once. They suggest that the galaxy should contain not just life, but civilizations. And yet, when we listen carefully, the universe is quiet. The contradiction between probability and observation forces us to think carefully. If the universe is capable of producing life many times, then the absence of evidence demands explanation. One possibility is that life itself is extraordinarily rare. On Earth, life appeared relatively early after the planet cooled. That might suggest that life begins easily when conditions allow. But we have only one example, one planet, one biosphere. It is possible that Earth represents an extreme statistical exception. The transition from chemistry to biology may require a sequence of events so improbable that it almost never happens twice. Life requires molecules capable of storing information, replicating themselves, and evolving. It requires stability long enough for complexity to emerge. It requires energy sources that are steady but not destructive. If any one step in this process is extremely unlikely, then the universe may be filled with habitable worlds that remain forever sterile. But even if simple life is common, intelligence may not be. For billions of years, Earth was inhabited only by microscopic organisms. Complex multicellular life required cooperation between cells. Advanced nervous systems required evolutionary pressures favoring perception and planning. Intelligence capable of building telescopes and transmitting signals is not an inevitable outcome of evolution. Natural selection favors survival, not curiosity. Dinosaurs dominated Earth for over 100 million years. They were successful, widespread, and diverse. Yet they did not develop technology. Perhaps the emergence of intelligent life is the true bottleneck. And even if intelligence arises, technological civilization may be fragile. Our own technological era spans only a few centuries. Our radio signals have been traveling outward for just over 100 years. On cosmic timescales, this is less than a blink. A civilization must survive environmental change, manage powerful technologies, and avoid self-destruction. As knowledge increases, so does capacity for harm. The same science that allows communication across space allows weapons of extraordinary scale. Intelligence brings power, power brings risk. If most civilizations destroy themselves shortly after developing advanced technology, then their lifetimes may be brief. In that case, the galaxy may contain many short-lived civilizations that rarely overlap in time. Two intelligent species could exist in the same galaxy and never know about each other simply because they did not exist at the same moment. Time may be a greater barrier than distance. Distance itself is formidable. The Milky Way is roughly 100,000 light-years across. Even if a civilization transmitted a signal, it would take tens of thousands of years to cross the galaxy. A reply would require the same time to return. Civilizations evolve. Priorities shift. A message may arrive long after its sender has transformed or disappeared. Interstellar communication is not conversation. It is patience, measured in millennia. There is also the possibility that advanced civilizations do exist, but choose not to announce themselves. Broadcasting one's presence to the galaxy may not be wise. Civilizations might prefer silence. They might observe quietly. They might communicate in ways we do not yet understand. Our searches assume that others use radio waves, that they expand outward, that they leave detectable signatures. But these assumptions reflect our own history. An advanced civilization may value efficiency over expansion. It may reduce its energy footprint rather than enlarge it. It may turn inward, exploring virtual environments rather than physical space. From our perspective, such a civilization could remain invisible. Silence does not require absence. It requires only non-participation. We must also consider how little we have searched. Our radio telescopes have examined only a small fraction of the sky across limited frequency ranges for a brief period of time. Concluding that the galaxy is empty based on such a small search would be premature. Yet the puzzle remains. The galaxy is ancient. If even one civilization had emerged millions of years before us and chosen expansion, its influence might be visible. The absence of obvious large-scale engineering suggests that either such civilizations are rare or expansion itself is uncommon. This leads to a deeper idea. Somewhere between lifeless matter and galaxy-spanning civilization may lie a barrier so difficult that almost no one passes it. A stage in development that filters out nearly all attempts. Whether that barrier lies behind us or ahead of us is unknown. The silence forces us to confront the possibility that intelligence is not merely uncommon, but unstable. If the universe should be full of aliens, and yet appears silent, then the explanation must lie somewhere between rarity and survival. The question is no longer simply where they are. The question is what the silence implies. One possibility is reassuring. Life is rare. Intelligence is rare. We are unusual, but not endangered. The universe is mostly empty because the chain of events required to produce awareness is extraordinarily unlikely. In that case, we are statistical survivors of a long sequence of improbable steps. The silence is not a warning. It is a reflection of scarcity. But there is another possibility, less comforting and more urgent. What if intelligence is not rare at the beginning, but rare at the end? On Earth, life survived enormous catastrophes. Asteroid impacts, volcanic winters, ice ages, mass extinctions. For billions of years, evolution continued despite repeated disruption. Yet technological civilization has existed for only a brief moment. In that short time, we have gained the ability to alter our planet, reshape ecosystems, and create technologies with global consequences. Intelligence brings power. Power brings risk. A civilization capable of transmitting signals across space is also capable of destroying itself. The same knowledge that allows interstellar communication allows weapons of enormous scale. The same industrial systems that enable exploration can destabilize climate and biospheres. Technological growth does not automatically produce wisdom. If most civilizations reach a point where their power exceeds their capacity to manage it, longevity becomes rare. Civilizations may ignite quickly and extinguish just as quickly. From a galactic perspective, they may resemble brief sparks in darkness, flashes that rarely overlap. If each technological society survives only a few thousand years, then the chance of two civilizations existing simultaneously within communication range becomes small. Even if intelligent life arises many times across the galaxy, it may almost never coincide. Time may be the true barrier. There is also the possibility that advanced civilizations evolve beyond our expectations. We imagine expansion, colonization, megastructures around stars. But expansion may not be inevitable. A civilization may choose equilibrium over growth. It may explore inward rather than outward. It may reduce its visible footprint, becoming quieter as it becomes more advanced. Our expectations are shaped by our own history. We expanded across continents. We built transmitters. We broadcast signals. But an older civilization may see risk in announcing its presence. It may exist quietly within its own system, technologically advanced yet observationally invisible. Silence does not necessarily mean emptiness. It may mean caution. And then there is the most unsettling possibility of all. The barrier may not lie behind us. It may lie ahead. The origin of life may be common. The emergence of intelligence may be common, but the survival of technological civilization may be rare. If so, the universe may not be empty of life. It may simply be filled with civilizations that failed to endure. The sky may be quiet because the noise has already ended. We often imagine alien civilizations as ancient and wise, but age does not guarantee survival. A galaxy that is 10 billion years old may have hosted many societies that rose and fell long before Earth formed. Their signals may have faded. Their structures may have eroded. Their histories may be unrecoverable. The silence we observe may not be evidence of absence. It may be evidence of impermanence. There is, however, another possibility. The universe is still young compared to how long it will continue. Stars like the sun can burn for 10 billion years. Smaller stars may shine for trillions. The future of the cosmos stretches far beyond its past. If intelligence tends to arise late in stellar lifetimes, then we may be among the first rather than the last. The silence may reflect early timing, not extinction. The galaxy may still be in the process of becoming aware. In that case, we are not alone in a dying universe. We are early in a growing one. Between these possibilities lies uncertainty, rarity, fragility, timing, distance, choice, destruction. Each explanation carries different implications for our future, but all converge on one fact. The universe does not guarantee that intelligence will endure. If awareness is fragile, then its continuation depends on decisions made locally, on individual worlds. The cosmos will not intervene. It will not preserve civilizations out of sentiment. Stars will continue to burn. Galaxies will continue to rotate. Space will continue to expand. Whether intelligence survives is a separate question. When we look at the night sky and hear nothing, we may be listening to absence, or we may be listening to history. The silence could mean that no one is there, or it could mean that many were there, and none remained. Until we know, we stand in uncertainty. The numbers suggest we should not be alone. The silence suggests we might be. Between those two lies responsibility. If civilizations are rare, then each one matters more. If civilizations are fragile, then survival is not automatic. If we are early, then what we do may shape what follows. The question, where are they, is not only about others, it is also about us. Will we last long enough to be heard? Will we navigate our most dangerous centuries? Will we become a long-lived civilization or a brief anomaly? The universe is vast. The timescales are immense, but the window in which intelligence exists on any given world may be narrow. Until we detect another signal, this planet remains the only confirmed place where the universe has become aware of itself. The sky is quiet. Whether it remains quiet may depend, in part, on what we choose to become.